So we have 7 Ultrasonics mounted on the front of the cart. They're twisted into the PVC pipes, and they're wired from the ultrasonic through the PVC and back to these connectors. Some of the connections are wired on this terminal block, and they run to the back of the cart. Right now it's not actually implemented in the code except for if you turn on the stop node.
And the problem we were having with the stop zone is that the ultrasonic sensors, as of right now, we didn't really have enough time to figure out how to denoise some of the signals. So periodically they'll detect something that's in the way that isn't in the way. And so eventually what you'd like to do is to figure out how to get the ultrasonic sensors giving reliable distances without noise, and then you'd be able to use them for that same purpose potentially. Or what would be better is to be able to understand where they are and where they're located, and then to use that distance in a transform in ROS and be able to add it to the laser scan, or somehow supplement the laser scan.
And this PVC is adjustable, so if you wanted to tilt them up or down, you could do that. You can also move them side to side. Anything else?
Yes. Then as we move, that's I guess it for the ultrasonic sensors. So some other things to be aware of in the front of the cart. Starting from the top, I guess obviously this is the LiDAR. The mount that it's on is adjustable, but be aware that if you adjust the angle of the LiDAR, you're going to have to adjust in software the transform that happens back to baselink. And so then moving down here, we have the sounder. So this is the sounder that's controllable via the pedestrian notification Arduino node. And this you can enable or disable based on whatever you want. Basically, right now we have it set for when the emergency stop region, when there's something in the emergency stop region, it goes off. It's very loud and very annoying, so just be aware of that. Right. So in addition to the sounder, we have this light at the top, which can be activated just like the sounder using the pedestrian notification library on Do82. And this we have set right now to turn on when the cart is in autonomous mode. But again, you can control the settings for when you see fit to activate this light. So following with the LiDAR, so you saw the mount, and then coming out of the LiDAR is a single cable. This cable goes around and through and into this box here. So this box is what actually takes the data from the LiDAR and then converts it into something that we can see on the Ethernet connection. So you can see we have a label on the top here which has the IP address for the LiDAR. Right now the network on the cart is configured, so you shouldn't have to touch that. But also in the theory of operations, there's a section that describes how to configure the network if you ever needed to do it for a new computer. But that's the IP address for it. You can see we have a white Ethernet cable here. So this actually goes through to the back of the box. So if you'll follow me around to the back of the box. So in the back of the box, we have a Ethernet switch here. So this is the white cable that's coming from that LiDAR box, and this is going into the switch. So in the switch we have 3 wires. We have the one coming from the LiDAR from the front, and then we have a wire going to the computer, and then we have one that's a spare here, and this is used for wired SSH debugging. So you'll be able to plug your computer into here and then join this static network that is on the cart for being able to have SSH access to the computer. We'd also recommend in the future that you get yourself some kind of wireless functionality just for convenience. So this is configured as a static network on the computer already, and if you have any questions about that, don't hesitate to contact us.